To build a professional character rig, your joints have to survive extreme stress. If we push a mechanical arm to its limits, twisting, stretching, and scaling the master layer, the furthest joints must remain perfectly intact and fluid. This shows where standard rigs fail. On the left, scaling a parent horizontally squashes the child. On the right, the child maintains a perfect circle. Standard parenting forces the child into the parent's coordinate space. When the parent stretches, the grid stretches too. To bypass this, we use a specific technique, non-destructive transformation inheritance via expression linking. Step 1 is preparing your workspace. Open your project settings and verify you are using the JavaScript expressions engine. This is the modern code parser in After Effects, and it is required to read the syntax we are about to write. With that enabled, we can abandon the standard parent column entirely. We will build structural independence using explicit mathematical links instead. Our first target is scale. We need to neutralize the parent's dimensional changes, so the child layer retains its original visual size. Select your child layer, press S to reveal the scale property, and hold Alt or Option while clicking the stopwatch. This opens the text box where we will write our expression. This diagram illustrates our code's inverse math. As the parent's scale grows to 200%, the child's scale automatically shrinks to 50%. Applied to a limb, the parent doubles, but the child mathematically shrinks, keeping its visual scale at exactly 100%. As you type the code to calculate this, check your syntax. A single missing semicolon or misplaced bracket will break the entire calculation and disable the rig. You must also ensure you are using the property-specific pick whip, not the general layer pick whip. The property pick whip is the spiral icon next to the specific scale value, and using it ensures we only pull the scale data rather than the entire transformation matrix of the parent. By linking these values through inverse math, the child limb is free from the parent's dimensional distortion while remaining physically attached to the joint. Next, we address rotation. Inherited rotation forces a child joint to spin rigidly along with its parent, which breaks the illusion of weight and gravity. We need independent rotation. If a character's torso bends drastically forward, the attached forearm should have the ability to stay completely level. To counter a ship's turn, a compass needle actively subtracts the angle, rotating in the opposite direction to stay north. Applied to an elbow joint, when the upper arm rotates 45 degrees, a counter rotation of negative 45 degrees keeps the forearm perfectly horizontal. Because we use the expression to establish a stabilized baseline, you retain full manual control. You can still set keyframes on the forearm to animate it independently on top of that stable foundation. This subtraction establishes a stabilized baseline for a rig that remains functional even under extreme torso rotation. Our final obstacle is nested precompositions. A nested precomposition is a separate composition timeline placed inside your main timeline, creating a box within a box. Here is why nested comps break standard expressions. The inner box has its own isolated 0-0 coordinate grid. This local grid clashes with the 0-0 grid of the outer master box, meaning a position value of 100 in the inner box means something completely different in the master box. To solve this, we apply the toWorld function to the child's position property. toWorld acts as a global GPS. It ignores the local coordinates of the nested box, calculating the true, absolute positioning of the layer within the master composition's global space. When you add this function to your code, it forces the child layer to snap to the exact absolute position of the parent layer, crossing the boundaries of as many nested layers as necessary to find it. By utilizing toWorld, you unify the entire character hierarchy under a single mathematical space, rendering the timeline boundaries irrelevant. Now we execute a final stress test on the completed character rig. We aggressively manipulate the primary parent layer, scaling, squashing, and spinning the core body to try and break the mathematical links we just built. Look closely at the extremities. The elbows and forearms maintain their exact dimensions and follow their independent trajectories, completely ignoring the chaos happening at the core. Applying non-destructive transformation inheritance guarantees this level of structural integrity. It allows you to build complex, multi-layered animations without constantly compensating for inherited geometry errors. Replacing the standard parent column with mathematical expression links prevents distortion and ensures the character's geometry remains consistent across the entire project.